Welcome to The Explainer. Today we're tackling a question that I think we've all felt. Why do our super smart AIs have the memory of a goldfish? They forget everything about us the second we close the tab. Well, we're going to dig into why that is, and then we're going to architect a solution using the most powerful memory system on the planet as our inspiration, the human brain. So let's just start with a really fundamental question here. You talk to an AI day in and day out. You teach it about your projects, your preferences, your style, but is it actually getting any smarter? Is the AI you talked to on Friday any more capable because of all those conversations you had with it on Monday? The answer, for almost every system out there today, is a pretty shocking no. See, an agent that just queries your past conversations isn't learning. It's just rederiving the same answers from the same documents every single time. Nothing compounds. The AI isn't building knowledge. It's just running a really, really good search query on a library of stuff you've already told it. So, why does it feel like memory if it isn't? Well, this brings us to the most common architecture in AI today, Retrieval-Augmented Generation. You've probably heard it called RAG. It's incredibly powerful for sure, but it also creates this illusion of memory. And to see why, we need to pop the hood and see how it actually works. Okay, so at its core, the RAG process is a pretty simple pipeline. First, you ask a question. The system then takes that question and goes hunting through a knowledge base, your documents, your chat history, for any relevant snippets of text. Then it takes those snippets and just stuffs them into the AI's short-term memory, the context window, right next to your question. And finally, the AI generates an answer based only on that temporary bundle of information. It's retrieve, answer, and then poof, it's all gone. And this slide right here gets to the absolute heart of the problem. Standard RAG is a read-only system. That means the agent is stateless. Every single time you talk to it, it's starting from a completely clean slate. It finds info, and then it immediately forgets it. True memory, on the other hand, is a read-write process. The agent can retrieve info, learn something from it, and this is the game changer, write that new understanding back into its memory for next time. That is how knowledge actually compounds. And because it's read-only, RAG is missing the fundamental building blocks of real memory. It can't build rich associations between ideas, connecting a fact to when you learned it or why it was important. It retrieves raw text without any deeper understanding. And maybe most importantly, it has no way to forget, which, as we're about to see, is a critical feature, not a bug. And look, this isn't just some academic argument. One developer put it perfectly when they said, if you're building AI-powered search, maybe RAG is a good approach. But if you're building agents, RAG is not enough. The second you need an AI to do more than just one-off Q&A, the second you need it to learn, to adapt, to build on past work, RAG just hits a wall. All right, so if RAG is just a fancy search engine, what does real memory look like? Well, to figure that out, let's turn to our inspiration. Let's see how the human brain's incredible architecture gives us a blueprint for the next generation of AI. So, the brain has this brilliant two-stage system. You can think of it like a computer. The hippocampus is like your fast RAM. It quickly captures new experiences and surprising details. The neocortex, that's your stable hard drive, where permanent knowledge is stored. And at night, while you sleep, the hippocampus replays the important stuff, transferring it from that temporary RAM over to the hard drive. This separation is crucial. It stops new info from accidentally overwriting old, stable knowledge, which is a massive problem in AI called catastrophic forgetting. And here's another mind-bending thing about the brain. You don't replay memories like a video. You actually reconstruct them on the fly. Your brain pulls up a few key fragments and then fills in all the gaps based on what you know today. Now, this is why our memories can sometimes be a little unreliable. But it's also the exact same process that lets us imagine the future. We're using the same hardware to remember the past and to simulate what might happen next. This whole reconstruction process is powered by these incredible associative networks. I mean, think about the word beach. Your brain doesn't just pull up a dictionary definition. No, it activates this whole web of connected ideas. The feeling of sand between your toes, the sound of waves crashing, the smell of sunscreen, maybe a memory of a specific location. Current AI systems really struggle to build this kind of rich, multisensory web of connections that's so core to human insight. Okay, now for the most surprising part. Forgetting isn't a failure of our brains, it's one of its most critical features. As one neuroscientist put it, we are forgetting machines. Our brain is constantly actively pruning old, irrelevant information. Why? to reduce noise, to help us generalize, and to adapt to a world that's always changing. A memory that remembers everything perfectly isn't smart, it's broken. So let's take these amazing principles, the two-stage system, reconstructive recall, and especially active forgetting, and see how they're inspiring completely new AI architectures. This is where we go from theory to actually building a better AI brain. The single biggest leap forward is right here. It's this fundamental architectural shift from the static read-only world of RAG to a dynamic read-write architecture. The whole goal is to give the AI the ability to actually change its own state, to learn something new and then save that knowledge for the future. Honestly, this is the chasm we have to cross to get to true AI memory. And we do this by giving the agent right tools. So instead of just searching, an agent can now actually add a new fact to its own knowledge base. It can invalidate old information, like it can learn that Kai works on Project Orion was true in January, but it's not true anymore in March. It can even keep a kind of diary of its own thoughts and conclusions. And this is how knowledge finally starts to compound. This read-write idea has just sparked an explosion of new memory architectures. For example, vector memory is really good for fuzzy stuff like user preferences. Graph memory is even more powerful. It stores facts as a network of relationships, which is perfect for complex reasoning. Some systems are even baking knowledge directly into the model's weights. That's parametric memory. And others are using structured local files on your own machine, which is great for privacy and costs nothing. Each one is like a different tool for building a smarter AI brain. Now, I want to circle back to that really counterintuitive idea of forgetting. It's so important that it really deserves its own focus here. I mean, why on earth would we intentionally build an AI that forgets things? Well, just like we heard from the neuroscientists, our brains are optimized to forget. And it's not a flaw, it's a core design principle for any efficient adaptive system. And honestly, it's a principle that AI desperately needs to learn. See, without active forgetting, an AI's memory just becomes a cluttered digital attic. First, you get information overload, which makes finding the right memory slow and expensive. Second, it clings to outdated information, mixing up old project specs with the new ones. And finally, all of this leads to contextual confusion, where the AI just can't adapt when your priorities change. Forgetting isn't about losing data, it's about staying relevant. So what happens when you combine these powerful read-write abilities with associative networks and smart adaptive forgetting? Well, you get the foundation for a truly living, evolving AI memory. So let's take a quick look at where all the research is headed. The frontier of AI memory is just incredibly exciting right now. We're seeing these hybrid neurosymbolic systems that combine the creativity of neural nets with the hardcore logic of traditional AI. Researchers are building hierarchical memories that actually mimic the brain's short, medium, and long-term storage. They're creating systems that can understand cause and effect over time. And maybe most importantly, they're building these sophisticated forgetting algorithms that allow an AI to strategically decide what's important enough to keep and what it's time to let go of. And that really brings us to our final provocative thought. As we get closer and closer to building an AI with a truly human-like memory, we start to realize something. The goal isn't perfect, infinite recall. The real challenge, and maybe the true sign of intelligence, is building an AI that has the wisdom to forget. So what would a truly wise AI choose to let go of? It's a question we're going to have to answer a lot sooner than we think.